In this video, we're going to talk about what are composite functions, what are the conditions for a composite function to exist, what are the steps to find the formula of a composite function, and the range of a composite function. Alright, so start off with what are composite functions. So in simple terms, composite function is just a combination of two or more functions into one. Right? So in terms of a diagram, let's imagine that we have a conveyor belt and a big machine. Okay, so a composite function in this case, we call it a GF. Okay, that means it's made out of two different parts of the function. So we think of it as a big function first. So we know that if you have an input, you get an output. Right? If you input x, you get GFX. Okay, this is a function. But because it's a composite, I know that it is made up of two different functions, two or more. In this case, two functions. So if I have a X-ray eyes, look into the function. So this is roughly how it looks like. Okay, if I have an input x, so the input will go through the first function first. Okay, in this case f. So take note of the naming. GF means you go through f first. Okay, so if I have an input x, it goes through f, and I will get fx out of the first machine. Right? So this is a value which I will straight away input into the second machine. So the second machine is G here. So G will take this as an input, okay, and output this thing. So you can see that the fx is treated as the input of G. That's why it returns this value over here. Okay, so this is the idea of a composite function. Okay, you made out of two or more. You can have three. Just imagine there's one more function in the big machine. Alright. So in words, what it means is that if I have an input, okay, this input will go through the function f first, again because of the naming, f comes first, okay, to get fx, and then this fx will go straight into the function g. Okay, so in terms of the color, hopefully this helps a bit now. So fx is treated as the input, is inside the red bracket. Right, this is the input of the function g, so you put it inside the function g. So this is the composite function. Okay, it goes through f then g. So some other notation that you might see in different textbooks or stuff like that. So the first one is with the dot. Okay, g dot f. Alright. Second kind is the bracket form, the g bracket f bracket x. Okay. The last one, probably the more common one, is just GF. They will just call it GF bracket X. Okay, so just take note, this means it's a composite function. You go through F first, then G. Okay, some other notation, okay, in case you get confused when you see them the first time, okay, next time. So let's say you see a F square. Okay, it's not actually square. Okay, this is just telling you that you go through the machine F 2 times. So what it means is actually this. Okay, kind of f dot f. You go through the function f, and then you go through the function f again, right? So one thing to take note is that the f2 over here, it doesn't mean it's f square. Okay, if you want to represent f square, you need to put a big bracket then square. You don't just put as a power of f like this. Okay. Okay, so for the existence condition, what we understood just now is that the input x, right, it will go through the function f first to become fx, and fx will go into g. So if there will be any problem, probably it will happen in this middle part over here, because we need to make sure that this fx, it is a feasible input, right? Imagine if it's not a feasible input, then it doesn't go in. Okay, the machine G will encounter an error, right? So this is what we mean. Okay, we need to make sure that the output of f, okay, because it goes straight into G, we need to make sure that it is a feasible input of G. Okay, so the output of f is what we call the set, right? The range of f. Okay, I need to make sure that this range of f, this set of output, it is a feasible input for G. Okay, it is a subset of the domain. Remember domain, right? It's the set collecting all the feasible inputs. So I need to make sure that it is a subset so that f can be inserted into the machine G. Okay, so remember this is the condition for a composite function to exist. Okay, for GF to exist, you need range of f to be a subset of domain of G. Okay, finding formula in a composite function, usually it's pretty straightforward lah. Okay, so we just use this example and it should be pretty clear. So suppose I want to find the formula of GF. Okay, so what you can do is the bracket form will be helpful in this case lah. Okay, I'll write it as a bracket form. Okay, and I will just replace fx by the formula. Okay, because the formula just represents the output of f, right? I just put it inside here. Okay, this output will go straight into the machine G. So what I need to do now is simply replace x, okay, by x squared plus 2. Because that's what you did here, right? You replace x by x squared plus 2 into the formula of G. So that's what's happening here. Okay, of course the last step is just a simple simplification. Just simplify the formula. Okay, so to describe simply, you just replace x in G with fx, and then you simplify. Okay, when I say replace, it just means this step over here. Okay, alright, so that's the form to find the formula. Okay, so now to determine the range of a composite function. Okay, for a start, it feels like to find the range of a composite function, it will just be the range of G. It feels like that lah, because you start with f, right, the function f. So the function f will pass to G, so the output should be the range of G, right? It feels that way, but the problem is actually due to the function f. Okay, I shouldn't say due to, but kind of. So what happens is that given the domain of f, we pass through the function f, right? Or this input over here, we pass through the function f, and I will collect all the possible output, which is what we call the range of f. This range of f will then be inserted into a machine G, right? So what we can understand from this simple diagram is that instead of this red circle here, which is the domain of G, okay, I'm not going to use all the numbers in the red circle. I'm just going to use a small subset, which is the range of f. Okay, this range of f, I will put it into or put it through a machine G to get this output. Okay, so the actual collection of all the possible output is actually this blue circle here, not the big red one, simply because of this part over here. I'm not using the red circle to put into the machine G. I'm using this smaller blue circle. Okay, so what we have is that, okay, because we are taking the output of f, putting into the function G, okay, so this becomes the restriction. Okay, so let's just move on to the next one. So I can say that if you want to find the range of the composite function, which is the blue set over here, what you need to do is simply you restrict, or you can say to replace the domain of G with the range of f, right? Because now I'm not going to use the full red circle, I'm just going to use the smaller blue circle, and I treat this as my new domain, the domain of G, right? And I try to find what is the range of G, right? I use this new domain, I find what is the range of G. Okay, this new range will be the range of G of f. Okay, so from the diagram itself, it is pretty clear to see that if you are interested in the domain, because just now we are talking about the range, right? So for the domain, you can see that the domain of GF, which is like the big green function, right? The domain is this blue set, the blue circle over here. So the domain of GF is just the domain of f, because they start with the same set, right? So this two is equal. Okay, so let's look at a example here to see how we can find the range of a composite function. Okay, this should clear any doubts that you have previously. So to find this the range of GF in this case, so first step, I'm supposed to find what is the range of f first. The range of f in this case, because my function is pretty simple, it's 2x minus 1. To find the range, I can simply sub x equals to 2 and sub x equals to 5, and they will tell me the minimum and maximum value. Okay, again, simply because this function is a increasing function, it's a straight line, right? Okay, so you can just sub the endpoints. So if you substitute inside, you should get 3 and 9. Okay, so this is my range of f. This range of f, okay, step 2, I just need to treat it as the domain of G now. right? The domain of G initially was 0 to 10. So right now what I'm supposed to do is to use 3, 9 instead. Okay, so I will consider this function. Gx equals to Ex, okay, but my domain is 3 to 9 because of this. Okay, and I will go ahead and find what is the range of this new function. Okay, so the new range in this case again is pretty easy because e to the power x is also an increasing function. So if it's an increasing function, if you recall from the previous videos increasing function, I just need to substitute the endpoint. If I sub 3, the left endpoint, it will be the minimum value. If I sub 9, it will be the maximum value. Okay, that's why my new range is e to the power 3 to e to the power 9. Alright, so this range will also be the range of GF. Okay, hopefully you get the steps. Okay, let me just repeat Find the range of f first, because f is the first function that you deal with. Find the range. Use this range as the new domain of G. Alright, so under this new domain, find the new range of G. This new range will be the answer, the range of GF. Alright, so that comes to the end of the video. Hopefully now you can describe what are composite function, what are the conditions for composite function to exist, the steps to find the formula, and how to find the range of the composite function. Okay, see you in the next video.